Hey, welcome back to our Calculus 3 class notes. We're now on page 86, example 76, and this is our first example for how to calculate a double integral. So we want to calculate the double integral over the region R is down in the xy plane, of f of xy dA. Okay, so, and I want the function f of xy to be 100 minus 6x squared y. So this is a picture of it, and this is an example right out of your book because I wanted to get a good picture of what was going on. Okay, so this is z equals 100 minus 6x squared y, sitting over the rectangular region R, where x varies between 0 and 2. So this is the x-axis. X goes from 0 to 2, and y goes from minus 1 to 1. So it's the piece of the function that sits above just that rectangular region. Okay, I could have done this as dx dy or dy dx, so I'm going to do both and show you how you get the same answer. So the double integral over R of f of xy dA is the integral. If I'm going to go dx dy, so the y goes with the outside integral, so that's minus 1 to 1, and the x goes with the inside integral, 0 to 2. So when you integrate 100 minus 6x squared y, you integrate the inside integral first with respect to x only. That means you treat y's and any other constants as constants, treating the y as a constant as well. So I get 100x, and then the integral of x squared is x cubed over 3, so I get minus 2x cubed, and the y is just a constant, so just leave it there. And then I usually write, that means this 0 and 2 were for x, so as x goes from 0 to x equals 2, and apply the fundamental theorem of calculus here. So you plug in 2 first, so you get 100 times 2 minus 2 times 2 cubed times y. Minus, plug in 0, so I just get 0 when I do that. So that's the fundamental theorem. Simplify this, I get 200 minus 16y. And that is what's left to integrate the outside integral, respect to y. Integral of 200 minus 16y dy. So I integrate with respect to y, I get 200y minus 8y squared, right? Integral of y is y squared over 2, so I get 8y squared. Now in this very last integral, I don't necessarily need to write y equals minus 1 up to y equals 1 because I know that's the last variable I have, so I know that is for y. So I plug in 1, I get 200 minus 8, minus, plug in negative 1, I get minus 200 minus 8. The minus 8's cancel, and I end up with 400 cubic units. Or I could have integrated that instead of dx dy as dy dx. So now the negative 1 to 1 goes with the inside integral because that goes with y, and x goes from 0 to 2, the outside integral. So now we integrate first with respect to y, integrating from inside out. When I integrate with respect to y, I get 100y. The 6x squared is a constant, so I get y squared over 2, which gives me minus 3x squared y squared. And I'm evaluating that from y equals minus 1 to y equals 1. Applying the fundamental theorem, I plug in y equals 1, I get 100 minus 3x squared, minus, plug in y equals minus 1, I get minus 100 minus 3x squared. The minus 3x squareds cancel. I just am left with 200. So now that is what I integrate with respect to x. Now the inside integral is evaluated, so I now integrate 200 dx. So that's 200x, evaluated from x equals 0 to x equals 2, which I don't need to write because that's my only variable left. So I just plug in 2, minus plug in 0, and I end up with 400 units cubed again.